As a society, we are called to address the complex challenge of mitigating climate change and creating a better and more sustainable future for all. But meeting these challenges requires never-before-seen innovation coupled with widespread deployment of new and emerging energy technologies.
And much of this is already happening offshore. Countries around the world are opening new offshore frontiers by harnessing technology to develop offshore wind and floating solar, while also producing hydrogen and capturing carbon offshore. In the United States alone, offshore wind is forecast to grow significantly over the next decade, with more than 13 offshore wind projects expected to come online by 2026.
Likewise, new developments in floating solar have helped expand on a decades-long innovation of utility-scale solar, while solving complex water conservation issues around the world. And others are championing green hydrogen production offshore and harnessing the power of ocean currents and waves to produce energy. With growing momentum for renewables in the offshore space, the future of energy looks bright.
And this August, the industry's best and brightest will convene in Houston for the Offshore Technology Conference to discuss, deliberate, and share ideas, forging the path to a low-carbon future. We hope to see you there.
Hello, I'm Craig Jones. The development of marine renewable energy projects globally is demonstrating the feasibility of renewables in energy portfolios and the blue economy. As such, there's an urgent industry need to establish design standards and reduce costs and time associated with deployments. Our panel today brings together 3 experts in the field to have a discussion on pathways to a successful marine renewable energy industry, and to discuss ways in which other offshore industries can help accelerate marine renewable deployments. The Offshore Technology Conference is pleased to host Jennifer Garson with the U.S. Department of Energy, Rins Delisman with Sea Power, and Jonathan Colby with Verdant Power. Each of our panelists will give a brief overview of their work in the marine renewable energy space, and then we'll have time to address your questions afterwards. With that, I'm pleased to introduce Jennifer Garson, the Acting Director of Water Power Technologies with the DOE.
Thanks, Craig. Excited to talk to all of you today. So my name is Jennifer Garson. I'm the Acting Director for the Water Power Technologies Office at the U.S. Department of Energy. And today I'd like to talk a little bit about, both the pathways that we see for uses of marine renewable energy, both now and into the future, and some of the ways that we're thinking about how marine energy can really touch different areas within the blue economy. So a little bit about our office first. The Water Power Technologies Office of the U.S. Department of Energy is a $150 million program, which comprises of 2 main areas, our hydropower research, and then importantly for this conversation, our marine energy portfolio, which includes multiple technologies at scales that capture different types of resources associated with marine renewable energy. So that includes wave, tidal, river, and ocean current, as well as ocean thermal. Additionally, we're looking at pressure and salinity gradients as an expansion for the interpretation of marine renewable energy. So for marine energy, the resource potential remains theoretically large. Whether you're looking at the potential for tidal or for wave, you're looking at potential for providing power to a substantial amount of the population, both domestically within the US and globally. Marine energy is also uniquely suited for near-term and non-grid scale opportunities, like enhancing resiliency of coastal communities, offsetting fossil fuels through powering ocean observing and environmental monitoring systems, powering sustainable seafood and mariculture, and as an asset for disaster relief. Given its firm renewables futures, meaning that particularly for tidal, it's predictable, and locational benefits, marine energy has the potential to serve several large-scale industrial applications, such as clean hydrogen production and water desalination. For our near-term opportunities, which I'll get into a little bit more in a bit, We have a couple different research objectives, really looking at the potential for deploying tidal and current-powered systems and potentially wave for remote communities. And we are aware of many utilities in Alaska, in particular, that are looking for tidal and current power. And then we think about water-powered systems with having large impacts. Some of the near-term marine energy system markets that we're thinking about are aquaculture and food, desalination, particularly wave power, although also looking at tidal power for directly powering systems that desalinate seawater, carbon dioxide removal, so particularly looking at the potential for systems to monitor the amount of carbon removed from the system, as well as powering our scientific and observation systems to provide a better understanding of the ocean. But we do have many challenges and approaches for our marine energy. Right now, there are still fundamental scientific and engineering challenges in capturing energy from multidirectional water flows, and there hasn't been necessarily technology convergence. There still exist complexities in installing, operating, and maintaining devices in harsh marine environments, including getting devices into the water to really understand how these systems work when in an ocean environment. We've faced in the past prolonged design and testing cycles, particularly due to long and costly permitting processes, which has been exacerbated by limited access to testing infrastructure. We're still dealing with limited data on technology performance and end-use applications, and we need to develop a qualified workforce, including scientists and engineers, to address these challenges. However, given that that's how we've been thinking about the establishment of our own marine energy program mission, so really addressing some of those challenges through multiple different applications. So focusing on foundational R&D, so connecting our early stage R&D on things like components and controls and manufacturing of materials, improving the understanding of fluid structure interactions and optimizing devices for extreme conditions, among others. On our tech-specific design and validation, conducting in-water tests of industry-designed prototypes at multiple scales, everything from large-scale systems to those powering ocean observing. Reducing barriers to testing, so actually investing in the infrastructure really needed to develop and validate these technologies, as well as developing the environmental monitoring systems and tools to pre-position these types of solutions and technologies, particularly for regulators or for end users to understand the interactions of these types of devices with marine life. And then improving our data access and analytics. So investing in the use of data and tools, our STEM resources, and increasing awareness of marine energy technologies and lessons learned to really reduce the time, cost, and uncertainty for marine energy permitting and develop a skilled marine energy workforce. One of the things I wanted to talk a little bit about today, though, is our Powering the Blue Economy initiative. So this was launched in 2019. Really looking at, if we're still ultimately pursuing solutions for grid scale applications, are there other near-term markets that really could benefit from both the location and the type of systems that marine energy could provide to provide more near-term market applications? So both near shore for things like disaster recovery and resiliency and desalination, and deeper offshore for offshore aquaculture and ocean observing. Over the last couple of years, we've engaged over 200 customers. We've made more than 140 awards, including 7 regional innovation hubs and 5 community-based organizations. And we're working with many different agency partners to make this all a success. And so what are the goals, tools, and objectives of the Powering the Blue Economy initiative? Well, this is where we're looking to assess the value of marine energy in these different markets. So really working very closely with end users to better understand and articulate how marine energy can meet some of the needs and objectives in these markets. And then developing and deploying marine energy technologies based on end user needs. So really thinking about the coupling of the needs with the technology types and topography and resource capture, and accelerating marine energy technology readiness through some of these early near-term markets. So we have the dual benefit of both understanding how devices perform in the water at a smaller scale, but they still provide an inherent value even at these smaller scales for these end users. We're using multiple tools to achieve these objectives, including powering ocean observing through our Ocean Observing Prize and our Waves to Water Prize, which is focused on wave power desalination. We've made an increased investment even in our small business innovation research and STTR program on marine energy co-development over the last 2 years. We're developing lab R&D for community-centric partnerships for solutions, really looking at some of the foundational lab R&D too, at addressing some of the critical challenges like interaction with devices. And we're supporting our innovation ecosystem. So we're investing both in the organizations that have more capacity to support commercialization and connections to investors or end users, and then investing in our testing and infrastructure. So this past year, we made several investments in our national laboratories to focus on things like ocean observing. And then within our community, we're really making this an expansive effort to include our national labs and universities, small businesses, our both existing portfolio innovators, which you're going to hear from two fantastic ones right after me, and then even increasing new portfolio innovators as well. So this, this type of approach where we have both communities, tools, and the funding associated with it, we really think there's an enormous promise for marine energy to serve these markets. And so we're doing that through creating this, more thriving marine energy innovation ecosystem, funding the startups and entrepreneurs necessary to really advance these technologies, investing in lab and testing facilities, so everything from large facilities like our PacWave facility, which is out in Oregon, to smaller scale facilities that enable more blue economy applications. Really focusing on our end users and adoption. So both understanding what are the needs of end users and providing the resources necessary even to our developers to connect with those end users and investors, but still continuing to do a lot of research and development. A lot of the systems that we're looking at represent new novel technology approaches, even for existing market applications. So in addition to funding innovation, we still believe that there's a core R&D objective. And already we've seen a pretty robust portfolio. So this is just a snapshot representation of the different ways that we've been investing in marine energy and the blue economy. But we really feel like there's an opportunity for technology advancement, for advancing marine energy to suit many needs in this really robust, growing $3 trillion plus blue economy markets. And marine energy is uniquely suited to provide power to these types of systems. So with that, I will turn it back over to Craig.
Jen, thank you very much. That's an excellent overview and great to hear from the DOE on where we're heading with marine energy. Next, I'm pleased to introduce Ren Sleesman, who's the CEO of Sea-Power.
Great, thanks, Craig. As Craig mentioned, CEO of Sea-Power. Sea-Power is an ocean energy company. Specifically, we focus on wave energy. And I'm going to build a little bit on what Jen just talked about with the powering the blue economy or PBE markets, and a little bit of how we view that those markets are unfolding here in the near term. First, though, a quick little bit of background about Sea-Power. So in addition to the PBE markets, we're also focused on grid applications, terrestrial markets. To get to this point, we've completed a significant amount of R&D and testing, both in the lab and in the water. Many thanks to the Water Power Technologies Office for their support there, also to the U.S. Navy for their support in getting us to this point where we've been able to squeeze our first product out that's been sold and is is being fabricated now. We've been able to gather 50 patents to date, with more filings coming actually this year. We've built US and UK operations, and we've also, I think, advanced to the point where we have a number of partners, industry-leading partners. You can see the logos down below, who are really instrumental to our success as we begin to commercialize our products. So real quick about ocean energy markets. Initially, most of the focus has been on terrestrial grid applications. And that, as I mentioned earlier, it's a focus for us. It's a focus for many in the industry. But there's been, as Jen mentioned, there's going to be focus moving to the left of that. And part of the reason for that is because the cost of energy is the main driver for those terrestrial markets. It's a hyper-competitive market, 3, 4, 5 cents per kilowatt hour here in the U.S. for wholesale energy markets, and so it's a difficult goal to get to. We will get there, but as we think about what's available to us today, it is moving to the left of those grid applications to some of the markets again that Jen mentioned, whether it's power at sea, energy storage, maybe it's providing clean water or digital connection, making connections at sea for data services. And part of the reason that this is a near-term opportunity is that the driver here is the cost of ownership or the cost of operation of maybe an asset, maybe a mobile or static asset offshore, or it's the ability to supplant the use of diesel at sea, which can be very expensive. But usually the driver here is not what is the cost of the next electron. It is helping to enable some future capability or enable something that's really just not even possible today. So there is this, what we would view a very large transformation that's going underway within the ocean economy. And part of that is because it is a very people and capital and intensive operation. The manned operational model at sea can be not only dangerous, but very expensive. And so there are a number of drivers underway that are trying to push the ocean economy into tomorrow. And it may be, again, lowering costs. Maybe it is trying to have residency for subsea robotics, maybe trying to increase safety, electrify, or even decarbonize operations. But where that leads us to is a more autonomous, connected, and clean future. The problem, however, is we hear often from our potential customers and partners is getting power into an asset and data out. I mean, the ocean, it is a power desert. It's a little bit of a water everywhere, but there's no power to be had. And I think that issue can be maybe a little bit better understood by what we call the 10 to 10 gap. So from about 10 watts to 10 megawatts, and we view this as the core of the PBE markets. Anything less than 10 watts, a solar cell on a navigational cardinal buoy does fairly well. For anything more than 10 megawatts, in the near term, offshore wind, whether that's fixed or floating, is likely to take that and provide that power. But in between, in this 10 to 10 gap, there is really a significant missing opportunity, and we think that that's what wave energy fills very well. But more specifically, what's going on within that gap, we see 4 primary applications. This is marine robotics, static data gathering systems, operating equipment, maybe that's for oil and gas or for other operations, and then unmanned surface vessels. Unmanned surface vessels is one of the 4 here that is coming in the future, but you can think about that a bit like as EVs started to proliferate, you plugged it into your garage, and then charging stations start to pop up at work or at shopping centers or on the interstate. And as those charging stations start to proliferate, the range, the efficiency, the effectiveness of EVs was able to spread and proliferate on land. We believe that the same will happen for unmanned surface vessels offshore. First, it's port charging, and then you start to work it at sea charging. But it's the same concept for all 4 of the applications here. And in answer to that, there's a new class of systems that we refer to as autonomous offshore power systems that are there to provide power, energy storage, and data capabilities for mobile and static assets. You can really think of an AOPS as the combination of a cell tower and a charging station and a data server all wrapped up into one package. And it can be powered by wave energy, tidal energy, ocean current, OTC. It really doesn't matter what the power input is. It is really the ability to generate power on a local basis, provide energy and data services for some type of payload, but also maintain your station. We have a demonstration coming up in Hawaii this fall. Just talk about that a little bit to give you more of an idea of what we're specifically talking about from an application perspective. This is a $4 million project co-sponsored by the DOE and Sea Power with significant support from the U.S. Navy also. System will be going in the water at WETS, which is off Marine Corps Base Hawaii and Oahu. You see Oahu in the smaller picture, and then a diagram of the WETS facility, which is grid connected. We will not be grid connected there. We'll be deployed in that little yellow box in the upper right of the chart. But that's about 80 meters of water, sandy bottom. The system is designed for the 100-year storm, actually at PacWave, which Jen also mentioned. It's about 2 kilowatts worth of generating capacity with 35 kilowatt hours of of battery storage. We see that this multiple kilowatt, really from about half of a kilowatt to 2 to 3 kilowatts, that is a big sweet spot, we think, in the PBE opportunities. And really the first 3 of those primary applications, robotics and data gathering systems and operating systems. On this device, we have 5 payload interfaces for a variety of assets to plug into. It's also part of the Navy's Coastal Trident 2021 program. Coastal Trident is the Navy's annual port and maritime security demonstration. We're able to piggyback this project onto CT21. So just real quick, what we are demonstrating. So you see the AOPS, that vertical stack, and then we have 4 assets that we will be supporting. A Saab Sabertooth operating in untethered mode for 3 weeks. It will dock. You can see a depiction of the dock, and it's tethered into our seafloor garage, which has the payload interfaces and the energy storage. But the Sabertooth will dock. It'll get its charge. It'll get a mission. It'll go off, do that mission. In this instance, it's a bottom survey and profiling, a zooplankton profiler from NOAA. It'll come back, dump its data to the dock. We'll upload that data through the AOPS to the cloud, to the data owner, and then a new mission will be downloaded, and we'll rinse and repeat that cycle for 3 weeks. We have a Biosonics environmental monitoring system. That's a static seafloor sensor, long-range acoustical system, part of the Triton initiative, which is also a DOE-funded initiative for monitoring, environmental monitoring around wave energy devices. And then lastly, we have a methane emissions leak detection system that will be integrated with a Fugro seafloor data gathering system. The Biosonic system and the Sabertooth will be deployed at the same time. Sabertooth will come out of the water. The Fugro system will go in, and then we'll be operating the 2 static systems simultaneously for the balance of the 6-month project. So with that, I just wanted to show real quick, just to give you a little more detail on the system, a picture of our DARPA project that really got us kicked off in the powering the blue economy markets. That's on the top. We use elastomeric station keeping system from EOM Offshore that contains fiber optics for data transfer, copper for energy transfer, and then it also provides the station keeping. It is a single line system, which we think is important going forward. And then the seafloor base unit is from ECOG. It's their Halo product. This one last picture here, and then I'll hand off back to Craig. This is the nacelle of our unit currently at NREL. You can see the SCADA system and the power electronics in the gray boxes there. NREL will be doing pre-deployment testing. That is a brand new hydraulically driven dynamometer, which NREL has put together. This is in the 2.5 megawatt dyno building for those that are familiar with the facility at Flatirons. And just to give you scale, you can see the picture in the lower right with us in front of it. So this is a small compact system, fits in a 20-foot ocean container, be shipped anywhere in the world, which is an important part of the design requirements here. But we can talk about that more a bit later. So with that, I'll close. Craig, back to you. Thank you very much.
All right. Thanks, Rance. That's an exciting view into what's happening with wave energy. Next, we have Jonathan Colby from Verdant Power speaking to us from the Verdant Power Room in New York City. So, Jonathan, to you.
Yeah, good afternoon, Craig. I hope you're doing well. Today, I'd like to talk about the Roosevelt Island Tidal Energy Project and our path to commercialization with a focus on risk reduction and increased scale. Obviously, thanks to OTC Live. I'm excited to be here. Glad to be chatting with Jen and Ranston, Craig, and you guys all together. So today, I'd like to let the pictures tell the story. And what we're going to do is talk about the Roosevelt Island Tidal Energy Project, our Verdant Power Gen 5D turbine, and the tri-frame mount. Significant funding support has come from the DOE for this work here at the Wright Project. And it was good to hear Jen talking about the importance of installation, operation, and maintenance, because that's been a really big focus of ours here at the Wright Project, and we'll talk about that. Testing is a huge part of the path forward, and it's a huge part of the work that Verdant's been doing at the Wright Project and through our turbine and tri-frame design. And I'll end today with some key takeaways, again, focusing on retiring risk and on how increasing scale can really drive the commercialization process. And so we will be coming, from the perspective of utility scale, grid connected here in New York. For those not familiar, the Wright project is in the East River, the East Channel in New York City. We have a Federal Energy Regulatory Commission, or FERC, license for up to just over 1 megawatt. This gives us regulatory consent for up to 10 tri-frames. Each tri-frame has 3 of our Gen 5D turbines with a 5-meter diameter rotor. Through the FERC licensing process, most of that information is publicly available. And so for those interested in all of the detailed environmental, consenting, technical, et cetera, details that are publicly available, there's, you can see our website, therightproject.com, and you can also find a lot of this through the FERC docket. And so what I want to talk about now is the actual execution of the technology and its performance under the FERC license at Wright. And so here you can see our tri-frame, which is the black steel and concrete structure that serves as a base for the 3 Gen 5D turbines that you see mounted here. This photo shows the final integration of those 3 Gen 5D turbines on the tri-frame at our staging facility in New Jersey. This entire system is loaded onto a barge, and the suite of barge assets and the tri-frame plus turbines are mobilized to the East Channel of the East River. Here you can see the tri-frame in its final deployment location above the water. You can see in the middle blue the lifting rig that includes a lifting pin, which is inside of the gray collar, the lifting link. This system lowers the tri-frame to the bottom from a predetermined location above the surface. You can see here we start a slow and gradual lowering of the tri-frame and 3 turbines into the river. You can see the tri-frame is fully submerged, and we're just approaching the turbines submerging. You can see that lifting link, again, the gray cone in the middle with the blue lifting pin apparatus. Continuing to lower, we see the 3 turbine nacelles entering the water. You can see the lifting link and pin apparatus are quite close to the water surface as well. We continue down, blade tips. When the lifting link and tri-frame reach the bottom and are level, all systems are go. We release the lifting pin from the lifting link and remove that from the river. And when we're done, you can see here, this is a view to the north and the east. Queens is on your right, East Channel, East River. You can see the 6 buoys that we use to maintain an exclusion zone. And this is work that's obviously done in close coordination with the United States Coast Guard and the U.S. Army Corps of Engineers, among a broad range of stakeholders. As a part of our testing campaign and to really advance the technology readiness level, or TRL, of the system, we conducted a retrieve and replace operation on an accelerated maintenance schedule. And so what would normally be a 3 to 5 year maintenance schedule was accelerated to 6 months. And after the first 6 months of operation, the tri-frame was retrieved. So here you can see the retrieval process. You can see the small amount of biofouling that has occurred over the first 6 months. You can see that the blades in particular have little to no biofouling, especially at the tips, which is where the velocities are the fastest. And so it's quite as expected that the blades would come out relatively clean, whereas the static nacelle, cones, pylon, fairing, etc., would show additional biofouling. And so not only did we want to prove that you could retrieve and replace this unit, we wanted to prove that you could swap out a turbine while you were on the transit barge. And so here you can see after the replacing of a single turbine of the 3 mounted on the tri-frame. This turbine is designed identically to the previous turbines. However, we had a really exciting opportunity to work with NREL on a new material application And so here, the new turbine is actually blades are made with thermoplastic. And so instead of the same material as previously, we're testing this thermoplastic material. And we've also instrumented these blades with a series of strain gauges to allow us to measure the stress and strain on these 3 blades during operation at the right project. And once we were finished with all of our on-water maintenance, we were able to execute a second deployment of the tri-frame, again, lowering the system to the bottom. Once the system was level and all electrical connections were good, we released the lifting pin and we began operating the second phase of the project known as period B. So I want to, step to some of the key accomplishments that we've just accomplished here at Wright. From a performance perspective, we are approaching 9 months of operation and have delivered more than 300 megawatt hours of electricity to the New York City grid through a distributed generation interconnection with Con Edison. And during the period of operation, we exceeded availabilities of 98%. And so from a turbine and tri-frame perspective, we are incredibly happy and pleased with the performance. Similarly, from a contractual performance, we're very pleased. All of the key metrics that were identified were met. Those were specifically on annual energy production, or AEP, on the availability, and on the cost. We did manage to complete the project on schedule and on budget with a pretty significant delay due to COVID. It was obviously being in New York City when all of it first started, there were some pretty significant interruptions to our operations here in New York, but we were able to accommodate those. Luckily, everyone in our company is safe, and we managed to deliver a very successful project, even though. And from a regulatory performance perspective, we're also very happy. We remain in full compliance with our FERC license articles, and I think we really have been good stewards of the East River and of our part of the East Channel. As we advance past the Gen 5D here at Wright and we learn from the lessons, I think we have been able to significantly retire risk. And there are some real areas in particular that I want to highlight to everyone and some of the methods and takeaways from our experience. And so first is that to retire the technical risk, we really relied heavily on international consensus-based standards. On the next level, we relied on international third-party verification. And so in this case, we actually brought in EMEC, the European Marine Energy Center. And in the first of a kind, they used their recognition as an IECRE test laboratory to issue an independent third-party verified power performance assessment, which really gives confidence and helps retire risk that the turbines we've designed performed as required and assessed by the standards and the certification system. We also really implemented the NREL risk management framework, which is a codified risk management framework based on TRL, and we believe that framework really helps mitigate technical risk. From an environmental and regulatory perspective, the concept of proportionality in our environmental monitoring, where the level of monitoring is proportional to the level of risk, can really help drive down costs, really help make environmental monitoring less onerous. And then doing all of your regulatory work under an adaptive management framework where decisions are based on data and on best practices, again, following international standards where available, is really an important way to retire risk. And then finally, from a project perspective, we have really implemented a holistic quality management and quality assurance and control system. And we really believe that has helped reduce our project risk. And then we have a long history here in New York, and we have built meaningful relationships with the stakeholders and with the community here in New York City. And I know from experience that the earlier you start that relationship building and the more often you communicate with people, the more likely you are to have success in a project. I think the next key takeaways, which Rent's really touched on levelized cost of energy and how important it is to drive down your cost of electricity or your cost of energy. As we at Verdant look to increase our scale, obviously you have the turbine geometry, and so you go to larger diameters in deeper water. Take advantage of that square proportionality. You drive up your AEP, ultimately lowering your levelized cost of energy. When you look at a project, you need to make sure you're in good, solid resource, fast water, take advantage of that cubic proportion, obviously. And again, here you're really driving up AEP. And that AEP has such a huge impact, or annual energy production has such a huge impact on your levelized cost of energy. And at the project level, you can also really start focusing, and you need to start focusing on availability and reliability, both of which will lower your operational expenditures or OPEX, again, further driving down that levelized cost of energy. And when you look at the fabrication and manufacturing at scale up, you really want to increase both your volume and your quality at the same time, really trying to lower your capital expenditures or your CapEx. So thank you. Verdant couldn't do it without a significant amount of state and federal support. So obviously, thank you to the Department of Energy, to our state partner, NYSERDA. And we have worked very, very closely with NREL, Sandia, and Oak Ridge over the last decade plus, and are grateful for their contributions to the right project. So thank you all, and it's been a pleasure. Thanks, Craig.
Thank you very much, Jonathan. And as a reminder to all of our participants, please put any questions or discussion topics you have in the chat. We do see those comments come through. One of our first questions, and I'm going to call out one of our audience members by name because I think it's useful to discuss the global perspective here as well. Elaine Buck, who's a technical manager at the European Marine Energy Center, had a question on how the marine renewable energy sector in the U.S. can tap into the Powering the Blue Economy community that you listed. And I'll direct that question first to Jen, and then definitely want to hear from Ernst and Jonathan their thoughts.
Yeah, so this has been a big emphasis over the last couple of years of thinking about not only how do you incentivize design of marine renewable energy fit commensurate with the needs of end users, how do we, even as the U.S. Department of Energy, try to fund or enable our marine energy, renewable energy development community to better connect with end users. So we've thought about this in a couple of different ways. One is by funding incubators and accelerators and other organizations that are more tapped broadly into the blue economy. So organizations kind of nationwide who have historically worked with blue economy market applications through WPTO funding to help support our marine renewable energy developers. Second is even by incentivizing through some of our public solicitations, like our SBIR programs, really focusing on end user needs as one of the drivers for even incentivizing, grants, provisions. Then even for our SBIR and STTR programs, we've been expanding our Energy I-Core program, which is connecting developers with basically customer-focused surveys where they have to go out and talk to end users and customers. But for WPTO, this is where we also work with some of our other counterparts and other agencies, is how do we really increase the connectivity between the energy community and the end users of energy that might have not realized that they need additional energy now to unlock the opportunities that they see in front of them. So we're doing also like end user customer surveys through our labs, really trying to think through how do we make that publicly accessible for our development community. So I think it's both, how do we fund the enabling environment like incubators and accelerators to be those intermediaries between our development community and people who need the energy? How do we think about the incentive from DOE's perspective of really focusing on end user adoption and strategies? And then lastly, the other thing that we're doing right now, even in the Water Power Technologies Office, is doing a technology to market and commercialization roadmap strategy over the next 12 months to really identify where we still see gaps in the portfolio to help support our development community at connecting to end users.
Excellent. Rens, what are your thoughts on the topic?
I think Jen was spot on with the end user applications and the interest. I put maybe add to that by saying it's all about the value proposition. So as one of my slides talking about lowering costs or improving safety or providing the ability to electrify, there has to be a reason and for the customer to want to get engaged, for the end user to want to get engaged, and maybe those are two separate companies or entities. But for instance, in AOPS, if you're able to replace a vessel offshore with a resident subsea AUV or ROV, Oceaneering did a project a couple years ago, so these are their numbers, not mine. But the savings over, I believe, a 2-week period was around $1 million. And they were able to avoid the deployment of a vessel in addition. And if you run that out on an annual basis, that's about 25,000 tons of avoided CO2 production. That's about 7,000 cars worth, I think, again, on an annual basis. And so that not only from a cost and an operational complexity, but also from a decarbonization perspective, there's really sort of a triple bottom line there for the customer. And I think that value proposition is what really will attract end users at the end of the day. And then the other half of it is just like any other business, which maybe the ocean energy business it's new to us, but it's really feet on the street. It is going to conferences like OTC in a couple of weeks and talking to potential customers, finding out what their problems are. So it's just sort of basic blocking and tackling. But I think, one, it's all about the value proposition and fulfilling a need, again, whether it's that 10 to 10 gap or improving safety or whatever the end use may be. And then at the end of the day, you got to get it out in front of people. And, having this application demonstration coming up off of Oahu this fall is just a perfect example of being able to pull all those things together and work in a co-development model, which the Water Power Technologies Office has pushed, especially through, I think, the SBIR program. But the co-development model, I think, is very important because it gives an opportunity for customers to potentially get involved without having to worry about a huge resource commitment. And reducing that friction allows them to get involved a little more quickly, a little more deeply, because it just reduces the corporate level of approval that has to go on.
Thank you, Rents. And I think an important point that you and Jen made, and Jen talking about looking at the customers and really finding out what the customers need, and Rents, the value proposition. And Jonathan, I think you bring a perspective of arguably a very large customer that you're servicing right now. What are your thoughts on moving forward?
I would certainly echo those. That the relationship building, I think is a piece that would tie through the various scales. And I mean, Rents used the word feet on the ground. It's very good, metaphor. And I do think that meeting the people that are interested, making the value proposition, and then fostering a relationship with those end users and with those stakeholders is very important.
Excellent. Thanks, Jonathan. So we had an early question on the environmental impact statements and environmental process for permitting. And this was regarding offshore wind. However, I think it is relevant for us to have a brief discussion on the permitting process, both from an environmental standpoint and just a general permitting standpoint. And Jonathan, I'd like for you to lead off. You, with getting your FERC license, have been one of the pioneers in really moving forward with the industry perspective on permitting. But what are your thoughts on lessons learned and pathways moving forward?
Yeah, we've had a lot of time to think about that. That's for sure, Craig. I think one of the early lessons learned that has been successfully applied in the later stages of the license is the concept of scale. And we introduced the notion that there's a micro scale, a mesoscale, and a macro scale. And at the micro scale, you're looking at single turbines and blades and the interaction of blades with individual species. And if you apply the correct technology to monitor the interaction at the micro scale, you can really answer some meaningful questions. And then at the mesoscale, you're looking at how species migrate or navigate through an array of these devices. And there are different but equally suitable technologies that can really answer questions at the mesoscale. And then at the macro scale, we're talking about like the dynamics of the harbor, which is very difficult. But there are some tools that allow you to measure macro scale impacts. And I think that macro scale impact is what the question from the cumulative impacts of wind starts to get towards. And once we codified the questions and answers about environmental impact into microscale, mesoscale, and macro scale, we were able to make some pretty significant progress by applying the correct technology to answer the correct question. And then the last piece I would say is once you start getting real data at the right scale from the right technology, that can be fed into statistical models that estimate the impact or the likelihood of impact. And we've been pretty successful in using real data to validate statistical models that really suggest the risk of impact is very low. And the regulatory community in the East River, New York Harbor, have generally agreed with our approach of targeted monitoring, statistical modeling, and then this adaptive management framework.
Excellent. Thanks, Jonathan. And Rance, it'd be good to hear your perspectives on the permitting you've dealt with. You're moving into test sites, which is another unique situation.
It's never easy for anyone involved in the permitting side because what we're doing is new, right? And I think once we get over the hurdle in each site and it becomes more frequent, it becomes easier. And I think a good example of that is the deployment we did in Puget Sound a number of years back. It took us a little bit to get it permitted and to get the everything lined up. That was originally a 6-month deployment, and then we were able to run it for another 6 months, and the process to extend was very easy. And then we decided we wanted to go for another 3 months, and it was I'll just say it was a piece of cake. And so I think as there is experience that's gathered and learning occurs and more comfort happens, more comfort is gained, then it becomes easier and easier. For the Hawaii project, we're putting in a very similar system to what we did in Puget Sound or what was deployed for the DARPA project a few years back with University of Washington Applied Physics Lab. But we're also using a Saab Sabertooth, and that Sabertooth operating in untethered mode, that happens every day all over the world. But so neither one of those two systems by itself should present too much of an issue. But we're combining them in a very unique, novel way, something that's really never been done before. So that we have to work through that. But I don't think that we've ever sensed that it is an insurmountable obstacle. But we're doing new stuff, and I think if it was easy, everybody be doing it. But it's just a matter of gaining experience and giving comfort from your regulatory side.
Thanks, Rance. And Jim, the DOE has done a tremendous amount of support into work on environmental impacts and helping look at more efficient pathways for permitting. Can you speak a little bit about DOE's support of the test sites and future plans?
Yes, and I will say, I know the original question was about wind as well. We do work a lot with our Wind Energy Technologies Office to understand commonalities, both at whether you're talking about resource assessment or site assessment or environmental technology applications to, almost to learn lessons from some of their work in environmental permitting. But yeah, permitting we understand is both a challenge, but also an opportunity, especially as some of these early devices that go into the water, to be able to provide, as Jonathan was emphasizing, some of the validated data about performance before we even go in for more permits. But for our environmental portfolio, we're developing both the technologies as well as the data synthesis and analysis to better understand the environmental impacts, so that when we go through a permitting process, it's not also a brand new novel thing for regulators. We even have several projects within WPTO focused on, how do we work closely with regulators to understand both the questions that would be necessary to answer and address in order to secure permits, but also better understand some of the data collection and methodologies that we should be concentrating on to provide confidence for regulators and other bodies that are basically the ones in charge of permits. But it's also one of the reasons why we invested in PacWave, was having a pre-permitted site for wave energy testing to better enable devices to go into the water more expeditiously by going through a pretty lengthy process for permitting. So we're both, investing in the permits necessary to do testing, as well as investing in environmental monitoring technologies and the data requirements that are necessary for being able to both provide confidence in the environmental assessments, but also make it easier, hopefully, in the future for environmental monitoring.
Thanks, Jen. And I think we have time for about one more question, and then we'll have some closing remarks from our panelists. The final question is regarding standards. So with Offshore Technology Conference, of course, focusing much on traditional offshore energy and about a 50-year history dealing in the offshore, standards are incredibly important. As all of you have mentioned, in a new industry, we're developing new standards. But Jonathan, I'd like to bring that to you first on where we are with the IEC standards. And I think it's worth announcing your role in the IEC standards as well.
Sure. So for marine energy, the standards are written under IEC Technical Committee 114. And as Craig alluded, I'm currently serving as the chair of TC 114. It's a role I've had for 4 or 5 years at this point, and something that I really enjoy. So TC 114 is growing. We are up to 29 countries globally who are providing subject matter expertise on the development of standards that are including wave energy, tidal energy, river, ocean thermal energy conversion, and then resource agnostic standards such as design assessment, design moorings, acoustic characterizations, etc. We have 17 published standards to date. The group has evolved 2 of our standards into a second edition. So we've already gone through 1 full maintenance cycle, and we have another 3 or 4 standards that are under maintenance now. A really important note I would like to make to everyone is that the strategic business plan of TC 114 is currently out for comment. It gives the guidance and maps out the vision and strategy of the standards work over the next 2 years. And we are welcoming and obviously seeking input from everyone possible to make sure that we are getting the feedback and input from all of the countries involved. So I hope that's helpful. If I might, Craig, we also are making significant progress on the certification side at the IECRE. And so if people are interested in either standards or certification, they should certainly reach out to me.
Excellent. Thanks, Jonathan. And Rens, I'd like to hear how your involvement in standards has helped with wave power.
Sure. Certainly, Jonathan. Jonathan is the Jedi Master here, and we in the industry appreciate his and everyone else's participation to get IEC standards, which we adhere to. And also just want to say that it's important especially with these PBE markets, as we're pushing into commercialization, is sector standards can also factor in. For instance, API's American Petroleum Institute standard, I think it is 17F, is applicable as we start to work with subsea control systems, subsea trees, and so forth in the oil and gas industry. So it's not only design standards, testing standards is IEC, and Jonathan is helping to shepherd those through, but there's also the other side that you need to worry about from an industry sector perspective.
Mm-hmm. Excellent, thanks. And Jen, I know the DOE has also been supporting standards efforts in the U.S. A few comments on that?
Yeah, I mean, the work of TC 114 is really critical because as you're trying to establish, industry standards, we genuinely appreciate how involved our industry has been, but it's going to be critical for both providing the confidence in these devices performing both domestically and internationally, and really making sure collaboratively as we develop technologies, we understand the implications that the standards will have on performance. So we've been deeply involved with IEC. We also work in other international venues too, to ensure that devices that we're developing in the United States also comport with international requirements. And to Rens's point too, that's one of the key things that we're thinking about within the blue economy markets, whether it's on standards in adjacent industries or other performance requirements. How do we start to capture that to make sure that as we're developing these co-designed devices that we're not only concentrating on the energy side, we're also getting a better understanding of some of the other requirements that are going to be necessary for specific market applications.
Mm-hmm.
And Craig, if I might, I would just say that without the support of the U.S. Department of Energy, the U.S. would not have the leadership role that it does in the international standards community. And so I know I'm certainly grateful, and I really want to thank the U.S. Department of Energy for their sustained commitment in the standards activities that has really led to the U.S. holding a significant and meaningful leadership role in the development of these standards. So just put that shout out.
I'll let Carrie know you gave that shout out.
Oh yeah, please let Carrie know for sure. That's great.
I have a staff member who she could go on and on about standards and working with Jonathan on standards. So thank you.
Yes, thank you, Jennifer. Thank you.
Thank you guys very much. And I'd like to hear from each of you a few closing remarks on thoughts you'd like to leave for the community, for our participants. And with that, Jen, I'll let you lead us off on that.
Well, thanks to Craig for convening this. It's always also really nice to hear other updates on both C-Power and on Jonathan's work. It's really an exciting time, I think, for the industry, in that we're finally seeing devices that are in the water performing and exceeding expectations, and really starting to better understand, how some of the work that we've done over the last couple of years is helping address some of the key, technical and engineering challenges. Where I think there's a really unique opportunity too within marine energy to be a thought leader too on creating more opportunities at understanding power and energy needs, particularly as it relates to the ocean. One of the things that we're seeing even internationally is the recognition of the ocean as a climate asset. And really the only way we're going to be able to unlock some of these opportunities is thinking about, both grid scale and non-grid scale applications for marine energy to unlock data, unlock hydrogen, unlock potential fuels. And I think, both the creativity of the industry and also some of the new players that we're seeing coming in is really, it's an exciting time to see where we can take the future of marine energy. So I encourage anybody who's listening in to, get more in contact with our marine energy developers or follow the Water Power Technologies Office, and really think about the application even of adjacent industries and technology lessons and learned and workforce that may be applied to marine energy. So thanks to Craig, thanks to Jonathan, thanks to Rents. This has been a good conversation.
And thank you, Jen, and thanks for the call out for involvement as well. Rinsed.
Sure. I'd also like to echo my thanks, Craig, for the opportunity to participate today. Also, thanks to OTC, Jamie, Asha for their assistance. And I think the biggest message from my perspective is that I believe that the promise of marine energy, it is being delivered today. I think, as Jim said, you've got a lot of systems showing up in the water doing great, like Verdant's system, and the DOE has been instrumental, especially in these PDE markets. I think it was a seminar in 2018, maybe in DC, where it really the spark happened for me. But that leadership, I think, is very important. We see it going on, worldwide, especially in the North Sea. In addition to here in the U.S., systems are starting to be sold. Customers are being engaged. Customers are starting to want to deploy devices in real environments, and I think that for me is one of the most exciting things that's happened, really, in spite of. We all know how difficult the COVID environment has been, and I don't need to dwell on that difficulty across the board. But I know our supply chain has suffered. They have struggled to get through and help us get the system delivered, and that doesn't make things easier, especially with the lack of personal engagement. But we're plowing forward and getting more systems in the water and starting to sell those. And I think for me, that's the biggest part of it, is that ability to help start to deliver the promise.
Yeah, exciting times. And Jonathan.
Indeed. Thanks, Craig. Really appreciate you including me or inviting me for this. As Ren said, thanks to the folks at OTC for all their technical support in the background. The steel in the water is exciting. And so certainly would, amplify that message. It's been exciting for us, but it's been exciting all around the world. It feels like my daily blasts are more full of news than they used to be, as an example. And, we're seeing really sustained funding in the US. We're seeing increased funding levels globally. And there is momentum in the marketplace right now. And I think I share that optimism and that excitement. We're seeing it in the standards. We're seeing it in more involvement in some of the conformity assessment activities. And these are all slow and steady steps towards the maturation of the industry across that whole spectrum of watts to megawatts. And so, yeah, I think it's a very exciting time for the marine energy sector. I think we need to seize on that momentum, and we need to achieve some of the goals that we've put forward. If we're being frank, we have missed some of our goals previously. So I think we ought to all think for the next 5 to 10 years is how to achieve the goals that we've set, and let's all get together and make that happen. Thanks, everybody. I appreciate it.
Thank you, Jonathan. And thank you all. Thank you very much to our panelists for bringing your pioneering thoughts and ideas here and showing where we are as an industry. Thank you to OTC and Jamie and Asha, who've been in the background, who've helped pull all this off seamlessly. And we really appreciate all of you joining us. And please reach out to all of us with all of your questions and thoughts moving forward into the future.
So if you're asking yourself why you should attend OTC this year, first of all, our world-class technical program that will address multidisciplinary topics. Every other year we have an exhibit floor. The exhibitors are very anxious to welcome face-to-face interaction with their customers. They've been wanting to talk to everyone face-to-face for the past 14 months, and in August they'll finally get their opportunity. We've experienced tremendous support from exhibitors, sponsors, registrants, and the general community in Houston who are all ready to see OTC come back in person at Energy Park. And we invite everyone to join us August 16th to the 19th.